All right, today we're going to do something a little different. We are going to reverse engineer an AI expert. We've actually got our hands on the blueprint, the real university courses that map out how we create the people who build these incredible, intelligent machines. So, let's open it up and see what it really takes.
At its core, this whole field is wrestling with this massive question. What does it actually take to build a mind? Now, we're not going to tackle this like philosophers. We're going to come at it like engineers. We're going to break it all down by looking at the training, the actual education of an AI specialist.
Okay, so here's our game plan. We're going to follow this blueprint piece by piece. First, we'll look at the foundational plan. Then we'll see how they forge the core tools. After that, it's all about architecting intelligence, weaving in the human algorithm, and finally, seeing how theory smashes into reality. Right, Act 1, laying the foundation. I mean, every big project, every skyscraper starts with a blueprint, right? A super detailed plan. Well, for an AI engineer, that blueprint is their university curriculum. This is where all the raw materials, all the basic knowledge get laid out for the first time. And here's the thing. Before you can even dream of building something like an artificial consciousness or even a basic machine learning model, you have got to master the absolute fundamentals. And it turns out the most mind-bendingly complex AI systems, they're all built on a bedrock of surprisingly simple but, oh man, incredibly powerful ideas. So, let's get into it. What are the first tools that this blueprint demands? You can think of these as the absolute must-haves for any digital construction project. They're the non-negotiable bedrock of all of computer science. And it all boils down to two key things: data structures and algorithms. Seriously, this is it. If we're sticking with our skyscraper analogy, data structures are like the steel beams. They're the framework that gives the whole thing its shape and structure. And algorithms, that's the concrete. It's the step-by-step process that fills in the gaps and binds it all together into something that's actually strong and useful. So one is organization, the other is the process.
And check this out. This is that foundation in practice. We've pulled this directly from the syllabus for an actual course, PCSD 303. And you can see the logic, right? You start with the real basics. Then you move into simple structures like linked lists. Then you level up to more complex stuff like trees and graphs. And only then do you get to the actions, the processes like sorting and searching that use those structures. It's a perfect, logical climb in complexity. And right from the very beginning, from Module 1, they're taught how to measure efficiency. I love this analogy. Think of it like a recipe. Time complexity, that's just how long it takes to cook the dish. Space complexity, that's how much counter space you need for your mixing bowls and ingredients. And a great AI engineer, they are constantly juggling those two things to build the best, most efficient systems.
But just having structure isn't enough. The real world is messy. It's uncertain. So for an AI to have any hope of navigating it, it needs to speak the language of uncertainty, the language of probability. And that's exactly where a math course like this one comes in. Things like random variables and Markov chains, they're the tools that let an AI make educated guesses and reason about what might happen next. And that's the absolute soul of machine learning. Okay, so our foundation of steel and concrete, our data structures and algorithms, is solid. Now it's time to start building up. This is Act 2. This is where we see how those foundational tools are used to build the superstructure, something that can actually start to think and solve problems on its own. If we peek at the objectives for this Foundations of AI course, you really get a sense of the big picture they're aiming for. It's not just about how to code, it's about what even is intelligence. How does a system hold on to knowledge? How does it draw logical conclusions? These are the big architectural questions for the mind we're trying to build. So how does an AI actually, solve something? Well, one of the first and most central ideas they learn is problem solving by searching. The chess computer is the perfect example. It's not just thinking about its next move. It's searching through a gigantic, branching map of every possible future to find the one that leads to checkmate. And this is a fantastic example of how a huge idea like searching gets broken down into real practical techniques. These here are different uninformed search strategies. The maze analogy is perfect. Breadth-first search is like checking every single hallway 1 foot in, then 2 feet in, then 3. Depth-first search is when you just pick a path and run all the way to the end, and only if it's a dead end do you backtrack. Each one is a different tool, a different algorithm for a different kind of maze.
Okay, but here's the pivot. Here's what makes this a truly modern blueprint. It's not just about code and logic. The building, the architecture has to stand in the human world. So this next part, Act 3, it's all about designing for people. It's about understanding context, and maybe most importantly, building responsibly. Now this might be the most surprising thing I found in this whole blueprint. This is a direct quote from the objectives of an engineering ethics course. It says the goal is to equip students to make ethical decisions and implement gender-sensitive practices. Wow, that's a powerful statement that an engineer's job isn't just to make things work, but to think about fairness, ethics, and human impact. And that leads to the big question, right? Why on earth do coders need to study ethics and economics? The answer, when you think about it, is incredibly simple. Technology isn't built in a lab and then left there. It's unleashed into the world. It has massive real-world consequences for society, for the economy, for you and me. And look at how they're graded in this ethics course. This is what's really fascinating. It's not an essay test about Kant. A whopping 50% of the grade is a micro-project, and another 30% is based on activities. They're not just learning theory, they're being forced to actually apply these ethical principles to messy, practical, real-world problems. And this focus on the real world doesn't stop with ethics. It goes straight into economics. The blueprint demands that engineers understand things like cost-benefit analysis and break-even points. Because, let's be honest, you can have the most brilliant piece of tech in the world, but if it's not economically viable, if it doesn't actually provide real value that people will pay for, it's just a hobby. Okay. A blueprint is a great plan, but it's still just a plan on paper. Now we get to Act 4, the stress test. This is where the rubber meets the road. This is the moment that all that abstract theory gets hammered into real, tangible skills, and it all happens under pressure. Just look at some of these sample experiments from the lab. This isn't just homework, this is real stuff. They're told to build a spell checker using a hash table, or implement the find and replace feature you use in your text editor. They even have to find the shortest path out of a maze filled with landmines. This is where theory stops being theory and becomes something you can actually touch and use. 50. What's 50? That's the percentage for the final lab exam. 50%. Half of their entire grade comes down to one high-stakes test. It all rests on proving one thing, that you don't just know the theory, you can actually build something with it. That right there is the ultimate stress test. So, after all that, after laying the foundation, building the architecture, designing for humans, and passing that brutal stress test, what do you have at the end? You get an engineer who is so much more than just a coder. The blueprint creates an innovator who has a complete framework for building things responsibly. Someone who's always thinking about efficiency, intelligence, and the human impact of their work. And so that leaves us with one last and honestly one very important question. We've just looked at the blueprint for the architects of our digital world. So with these tools, with this knowledge, and with this ethical training, what kind of future are they going to build for the rest of us?